Hey everybody, welcome to another episode. I am here with Michael from Nordic Ledger, and we are talking a little bit about where we are imagining for the network to go. So, Michael, maybe introduce yourself.
Hi, Michael, Nordic Ledger, calling from Finland with Caleb with James Delisles. My question was a little bit too complicated for me to even understand. I was trying to figure out how would this work in the end, but
Yeah,
it is the most complicated question that I could figure out. So I had to call up with Caleb, and try to figure it out.
Yeah, so it is a complicated question, and there's a couple reasons why it's so complicated because there's what we have now, which is basically Crypt bandwidth hard mining. It's a lot of fun, but it's not getting you on the internet. And then what we imagine that we're going to go to in the very near future, and then where we imagine we're going to go in the longer future, like where we see this project ending up, and that's the revolutionization of the internet. So what we have now, obviously, it's bandwidth hard mining. It's a lot of fun. It doesn't get you on the internet. We also have CJDNS, and CJDNS is relevant to this story because a lot of the CJDNS technology, the compact source routing, that is something that's going to come back to us when we start getting into where we want to go. So I want to talk first about where we're going, like in the immediate term, what we can be expecting to see by the end of the year. And that's going to be being able to get on the internet via your neighbor's Wi Fi or the Wi Fi of somebody that you're passing by, and then that getting you to your VPN. So I know it's not the most exciting thing in the world, but the way that we're doing it is via CJDNS, and that is why we that allows us to get to the third point, which I'm going to explain in a minute. So, getting into the second point in a little bit more detail, what is actually happening? What are we going to be doing? So, you're going to have a person with a device that could be a packet cube, or that could be whatever other type of device that is running the software, and that device is going to be beaconing out on the Wi-Fi saying, "Hey, I'm here and you can connect." And that's going to be kind of like an open Wi-Fi, but kind of not. Because here's the thing about open Wi-Fi. You can't really share Wi-Fi with your neighbors because, well, a couple things happen. When you open your Wi-Fi, everybody knows this. Number one, you're insecure because your neighbors can sniff and spy and watch what you're doing online, and that's not okay. Number two is that your neighbors are insecure because they're going through your Wi-Fi, and like people who run open Wi-Fi may be doing it for not the best reasons. So you don't want to trust open Wi-Fi. And number three is that if you're running open Wi-Fi, you don't necessarily know who's connecting to that open Wi-Fi, and those people could be doing things that might get you in trouble because they're exiting to the internet through your IP address from your ISP. So there are three reasons why everybody locks down their Wi-Fi and then they don't share the password with anybody. Now, where we're taking this is like an open Wi-Fi, but number one, it's always secure. You don't have to worry about the security because it's just there. It's encrypted. It's always encrypted. It's not like you don't need a password in order to encrypt something. They tricked us. They made us think that you need a password just to be able to use encryption. And no, you don't. Of course you don't. You can encrypt things anytime you want. Password is authentication. Encryption is, setting up an encryption session. So we can have encryption. We can have encrypted open Wi-Fi. That's kind of the number one aspect. But the number two aspect is that it's not getting you to the internet through the IP address of your neighbor there. It's getting you to the CJDNS network. And the difference there is that that's going to get you to your VPN. And so your neighbor is not going to be responsible for what you're doing because you're going to be going to your VPN that you already have a relationship with. And then the VPN is going to be the one taking responsibility for what you're doing on the internet. Then the other aspect of this is that the VPN is going to be able to pay the neighbor using packet cache. And so the VPN company is going to be doing the micro payments to the neighbor. Does that all make sense? Or do you have any questions about that?
No, that makes sense. I'm just more focused on how the actual connection to the packet crypt network would work.
So each connection is a unique thing here. The connection between the device that, let's say, the packet cube, whatever, We are envisioning that that's probably going to use the Wi-Fi Direct technology, because Wi-Fi Direct allows you to set up sessions without necessarily having internet access, and it doesn't require you to enter a password and that type of stuff. So we're envisioning your Android app, your iPhone app, it's just going to automatically say, "Up, there's a network, there's a connection. We're going to connect to that." Now, once that connection starts to work between those two computers, then over that, we're going to be tunneling CGDNS. And CGDNS, that kind of maybe know, maybe don't know, but that is its own thing. And the way CGDNS works, it's using compact source routing. It's detecting a route server. Once it detects a route server, it sends a request to that in order to find out how to get to where it needs to get. And then it gets the route back, and then it sends source routed packets through the CGDNS network. Does that
So
answer?
yeah, yeah, it did answer. So no, the day before yesterday, they or a week ago or something, they removed from the EU Parliament to suggest to remove potential customer privacy on internet, and that's like closing down the nodes of Tor network or similar networks. So what I was thinking was, can the ISP actually block the PKT nodes in the future?
It's a good question. I think that if they really want to, they can. But what's going to end up happening is, if you're able to make money with your internet and the ISP is trying to block you from doing that, then people are going to find a way around that. And if people need to buy a business line in order to get something a little faster, in order to get you to the internet, in order to get something that will get them to be back to making money again, they're going to kind of do what it takes. I mean, it's always disheartening when you hear states going the direction of like Myanmar, and forbidding freedom in the form of things like VPNs, and the technologies that make the modern world function. And I hope that people will explain to them that there is no future in going the direction of a country like North Korea. But yeah, it's always a conversation that has to be had with regulators and policymakers.
So it goes to a node. It always connects to a node to get to the CGDNS network, and then you're in the mesh network in the PKT packet crypt network, encrypted
Exactly.
network.
Yeah,
Yeah.
yeah. And then you get to your VPN provider, and that exits you back to the internet so that you can get to your favorite websites, which, I mean, let's face it, most people want to get to Facebook, basically. But you know what? It's okay. And we're gonna accept that until. But I mean, I see the future. I don't see Facebook as being the future. I see the future is going to be much more decentralized. But it's important to give people the freedom to reach the websites that is what they actually want to get to. It's not our position to tell them that they shouldn't. So that's kind of the immediate term. But when we talk a little bit about the longer term, this is designed in such a way that it will scale into the longer term fluidly. So what the longer term is, so think about, okay, you've got a packet cube, you've got it connected to the internet, you're sharing the internet with your people in your community. Now you take that another step. Imagine you don't have the internet, but your neighbor does. And you can then point a directional antenna out your window or on your roof to that neighbor, and then you can pick up the connection to them, and then you're able to get the internet the same way that you're sharing it with the neighbors of your house. You're getting it from the neighbor of the next house. And you got a CGDNS session here, you got a CGDNS session here. CGDNS just knows how to set up networks. You give it sessions, you give it connections, and it's going to build that network with the route server. So then now you're able to have the neighbor of the neighbor sharing the internet of the neighbor of the neighbor of the neighbor, and getting you back to the network. Now, that's kind of like number two. And number three is, let's imagine you've built a little citywide mesh. Now, this is a couple of neighbors, a couple of different neighborhoods, and they're all connecting together using, neighbor to neighbor directional antennas, internet connections. And then one of those people has a cable internet connection, one of those people has a fiber internet connection, one of those people has a Starlink internet connection or some other satellite based internet connection. Now you have a local network where it is impossible to turn that network off without cutting all three of those backhauls. Because if only one of them is still functioning, that network will continue to be able to route. And that's one of our fundamental objectives of this project, is to create an internet which cannot be turned off. That there is no kill switch. There's no way to turn the internet off. It's self-sovereign. So this is the next step, is the ability to connect people to people to people. And then the next step after that is the ability to take the bandwidth from one neighbor to the next neighbor can be subdivided into, say, 100 slots. So you have a 100 megabit connection from here to there. You break it into 101 megabit slots, and each one of those you sell into a decentralized bandwidth marketplace as an NFT. I say NFT, it's kind of fungible, it's kind of non-fungible. NFT is a good way to refer to it. It's not art. It is an actual physical, a right to something. It is a right to use the bandwidth on that link at that time. So once you buy that NFT, then you're able to go to that router, send a message to that router and say, approve, I am the owner of that NFT. And then I can then therefore please connect that network to this other network, and because this is how I'm going to use it. So where I foresee this going, it's not going to be individuals so much buying these. It's going to be companies. It's going to be like your VPN companies, and that's how the VPN companies are going to remunerate the people who are getting their neighbors on the internet. It's not just going to be payout per byte or per packet or something like that. It's going to be payment for the right to use that internet in over a period of time, like a month into the future. You buy that right, and then you exercise that right once you own it. And so just by allowing, pricing internet, it's a very difficult problem. When you have such a problem, it's often the right solution for it is to turn it over to a market and allow that market to price the internet. A lot of mesh network projects, a lot of incentivized mesh network projects have attempted to create an algorithm which would price bandwidth. And it's very difficult. Most of the time, they just admit to you, well, it works well enough, but we know it's not perfect. And I'm not ready to settle for that, because that's not going to scale to the size of the entire internet. So that's it was very important to me to make this something that controlled by a decentralized bandwidth marketplace, where the market can price that bandwidth. And by that way, also, this is going to create market signaling in order to tell people where they should install more bandwidth, install more Wi-Fi, more wireless, more fibers, more cables, more anything, in order to make the internet better.
Yeah, that's really astonishing. Uh,
Thank you.
so one more question at least. The node has
I'm
this.
not getting the sound right now. Something happened.
Sorry.
Maybe if you were to just type it into the chat, then I will. I'll just read it, and then I'll answer it. What an annoyance! Computers, they never work. Okay, so the question is, how do we get the connection to the main mesh network after connecting to the node? And I think that it's kind of a trick question, because the answer is that the node is the main mesh. So if you have a cube, if you have a device that you're hooked it up to the network, now that node is actually part of the entire CJDNS mesh network. And so when you have a connection to that, you are now connected to a part of the network. And that's a significant difference of CJDNS from a project like, say, Tor or I2P, is that with Tor, you need to have internet access in order to use Tor. You need to be able to connect to any given Tor node at any time, because that's how Tor works. It requires you to connect to this Tor node, and then you need to connect to this one, and then you need to connect to this one. With CGDNS, you can be connected to one CGDNS node, and you are officially in the network. It's just that all of your traffic will route through that one node. So that's the difference. CGDNS is a routing network, whereas Tor, it does route, but it routes for a different purpose. Is there any other questions, thoughts, comments? So the question is, do you think everyone is going to install nodes on their computers so that the PKT network is going to be 100% impossible to shut down? Yes, I do. I think that right now, every computer on the internet has TCP/IP. It has, it has IP routing, fundamentally IP packet handling capability. I believe that by 10 years from now, every computer on the internet is going to have CJDNS packet handling capability. And that it will make the internet fundamentally impossible to turn off, because it's going to separate the network service operation, that the service providing is going to be separated from the infrastructure. So you got a wire connection to something, perfect. You connect that wire, and then after you've connected the wire, then you will think about the rights to use that wire, and how the person who ran that wire is going to be remunerated for their effort. By splitting the infrastructure from the service. I mean, this is the same thing that Uber and Airbnb did. What Uber did was they split the operation of the taxi from the administration of the taxi service. And what we're doing is we're splitting the operation of the physical infrastructure, the boots on the ground stuff that you have to be anywhere in the world, you have to be physically present to do it, from the operation of the network, which is a very complex, high-end thing that you need to have a business in order to do it. So by splitting those apart, we create more competition on both sides, and we make it so that you'll have the opportunity, the option of hundreds, if not thousands, of different ISPs, even if there's only one telephone line coming to your house. And you're going to have it's going to be a network that pretty much cannot be shut down, because if you've got a little mesh network inside of a community, like I said, if you've got three different people have three different satellite providers, plus you have somebody using the telephone network, plus you have somebody using the cable network, plus you have somebody with a fiber, there's no way to turn off all of those uplinks. So that community is going to have unstoppable internet. And on that note, I think that pretty much wrap it up. I really appreciate your coming on, Michael. Sorry about the technical difficulty with the sound. Computers never work. That's just a reality. Nothing works all the time, as a friend of mine says. Nothing works all the time. No comma. And so I think we'll catch y'all on the next one. And until then, stay awesome.